In this lecture, I'm going to go over reference angle and how to use them. Consider angle theta greater than 0 in standard position. Well, the vertex of the angle would be at the origin. The initial side will be on a positive direction of the x-axis, and the terminal side of the angle will be in the counterclockwise direction, meaning that in order to get theta greater than 0, we need to go counterclockwise for the terminal side. So this is angle theta. The reference angle is an acute angle that the terminal side of angle theta makes with x-axis. So an angle is an acute angle if its measure is between 0 and 90 degrees. So in this example, in this drawing, this angle is the acute angle of our reference angle for angle theta. That's the angle between the terminal side of angle theta with the x-axis. So when our angle theta is greater than 0, that means we're going counterclockwise. So now let's take a look at different cases and see how we're going to find the reference angle. If our angle ends up in quadrant 1, the reference angle will be the same as that angle theta. So for example, if theta is 40 degrees, then the reference angle will be also 40 degrees. If angle theta is, let's say, pi over 3, which will be in the first quadrant, then the reference angle will be also pi over 3. Let's say theta is 405 degrees. So 405 degrees is like going 360 degrees, which is one time around the circle, and another 45 degrees. So in this case, the reference angle will be 45 degrees. Now let's take a look at if the angle ends in the second quadrant. As we showed earlier, this will be angle theta. and this would be the reference angle for angle theta. In the second quadrant, the reference angle will be pi minus theta, or in terms of degrees, the reference angle will be 180 degrees minus theta. So for example, if theta is 150 degrees, that would be in the second quadrant. So the reference angle will be 180 degrees minus 150 degrees, and that would be 30 degrees. If theta is, let's say, 2 pi over 3, then the reference angle will be pi minus 2 pi over 3. So instead of pi, I'm going to go with 3 pi over 3 minus 2 pi over 3. And this becomes only 1 pi over 3. So the reference angle for angle theta equal to 2 pi over 3 is pi over 3. Now let's take a look at the reference angle for angle theta when we end up in the third quadrant. This right here is our angle theta, but the angle that the terminal side makes with the x-axis will be the reference angle. In order to find it in a third quadrant, the reference angle will be our angle theta minus pi if it's in radians, or the reference angle will be theta minus 180 degrees if it's given to us in terms of degrees. So for example, let's say theta is 5 pi over 4, which is in the third quadrant. So the reference angle will be 5 pi over 4 minus pi, with a little bit of simplifying this, the reference angle will be pi over 4. If theta is equal to, let's say, 260 degrees, still will be in the third quadrant, and the reference angle will be 260 degrees minus 180 degrees, and this will be equal to 80 degrees. Now there is only one case left, and that would be what happens if our angle falls in the fourth quadrant. So this is our angle theta, and the terminal side makes this angle with the x-axis. That would be our reference angle. And how do we find it? The reference angle will be 2 pi minus theta if it's in radians, or the reference angle will be 360 degrees minus theta if it's given in terms of degrees. So for example, let's say theta is equal to 300 degrees, which is in the fourth quadrant. So the reference angle will be 360 degrees minus 300 degrees. So the reference angle for the 300-degree angle will be 60 degrees. Let's say theta is 7 pi over 4. So now it's in terms of radians. And the reference angle will be 2 pi minus 7 pi over 4. Now 2 pi is the same as 8 pi over 4 minus 7 pi over 4. So we can reduce this, and the reference angle for that would be pi over 4. Now, what are we going to do if our angle is not in a standard position? What are we going to do if theta is actually a negative value? So I want to find reference angle for angle theta equal to negative 150 degrees. First, recognize that negative 150 degrees is in quadrant 3. So we take our angle and add 360 degrees to it. And that gives us 210 degrees. Now 210 degrees is also in quadrant 3. Now how are we going to find the reference angle? The reference angle will be (210) minus 180 degrees, and that would be what? That would be 30 degrees. I want to find the reference angle for theta equal to negative 7 pi over 4. Now, negative 7 pi over 4 is in quadrant 1. So in terms of radian, I'm going to go ahead and add 2 pi to it. In the previous example, I added 360 degrees because the angle was in terms of degrees. Now this angle is in terms of radians, so I'm just going to add 2 pi. Now instead of 2 pi, I'm going to write 8 pi over 4. So this becomes pi over 4. So the reference angle is pi over 4. Notice that pi over 4 is in quadrant 1 as well. Let's do a couple of more examples. We want to find reference angle for theta equal to 1000 degrees. Now 1000 degrees is obviously more than 360 degrees. So we can go ahead and subtract 360 degrees from this to get an equivalent angle which is coterminal with a 1000 degree angle. So 1000 minus 360 degrees, that would be 640 degrees. Now 640 degrees is coterminal with 1000 degree angle, but it still is more than 360 degrees. So I'm going to do that again. And that would be 280 degrees. So that's another coterminal angle with a 1000 degree angle. Now 280 degrees is in quadrant 4. So our reference angle will be 360 degrees, take away 280 degrees. So the final answer is 80 degrees. So this 80 degrees is a reference angle for the original angle of 1000 degrees. Now let's do one with in terms of radians. We want to find reference angle for theta equal to negative 51 pi over 4. Negative 51 pi over 4 is negative 48 pi over 4 plus negative 3 pi over 4. So why did I do this? If I simplify the first one, I'm going to get negative 12 pi, then plus negative 3 pi over 4. And negative 12 pi is negative 6 times 2 pi plus negative 3 pi over 4. Now every 2 pi, it's one time going around the circle. So our original problem, our original angle of negative 51 pi over 4 is as a result of going around the circle 6 times clockwise and then continue negative 3 pi over 4. So our reference angle will be, so we are in the third quadrant. First, I'm going to take negative 3 pi over 4 and add 2 pi to it, so to make it positive. So instead of 2 pi, I'm going to put 8 pi over 4. And that becomes 5 pi over 4. And 5 pi over 4, it's in quadrant 3 as well. So now back to our reference angle will be theta, which is in this case 5 pi over 4, minus pi, do our simplifying, and our reference angle for the original angle of negative 51 pi over 4 is pi over 4. Now, how to use reference angle? To evaluate trig functions. First, we identify the quadrant then we find reference angle, and then the value of trig function is the same as the value of trig function of reference angle except possibly the sign. It could be positive, it could be negative, so they both could be the same, or one of them could be negative. For example, I want to find cosine of 135 degrees. The reference angle for 135 degrees is 45 degrees. But in the second quadrant, cosine is negative. So the final answer for this would be negative radical 2 over 2. Now let's say I want to find sine of 5 pi over 3. Five pi over 3 is in the fourth quadrant, and sine is negative. But the reference angle for the angle 5 pi over 3 is pi over 3. So the final answer will be negative radical 3 over 2. Now what if we want to find tangent of 585 degrees? 585, it's one revolution around the circle and then going 225 more. So 225 is in the third quadrant and tangent is positive, But the reference angle for 225 is 45 degrees. And of course, tangent of 45 degrees is equal to 1. Now let's do one example with negative angle. Cosine of negative 7 pi over 3. Negative 7 pi over 3 is in the fourth quadrant. Cosine is positive in the fourth quadrant, and our reference angle is pi over 3. And cosine of pi over 3 is 1/2. I hope this lecture helped you understand reference angles and how to use them in order to evaluate trig functions.